Dear students, welcome to online live class 5 English version. This is your Kamal sir. Alhamdulillah, I am fine. I hope you are also fine by the grace of Almighty Allah. Dear students, today we will discuss chapter 5. The title of chapter 5, multiples and factors. Dear students, you can see that already I have written some topics. We will discuss today about these topics in details. Now first one, multiples, then common multiples, LCM, factors, common factors, GCF. Then we will discuss prime numbers, prime factors, and our last topics, prime factorization. So dear students, we can start. At first, multiples. Dear students, what is multiples? Multiples of a number, in shortly if we say, it is our times table. Suppose, what is the multiples of 4? The multiples of 4 is 4, because 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, like this one. So they are the multiples of 4. So what is the multiples of 5? We can say 5, 5 twos are 10, 5 threes are 15, 5 fours are 20, and like this. Unlimited. Uncountable multiples we will be able to write, because we don't know how many multiples have 5. Clear? So this is our multiples. So in shortly we can say multiples means the times table. Now common multiples. Suppose this 2 1. The multiples of 4 are this and multiples of 5 are this. Now which number are the common multiples between 4 and 5? Suppose we can write another 20. We can write another 24, 28, 32, 36, 40, 44, like this one. And for 5 we can write 25, 30, 35, 40, 45, like this one. So they are the factors of 4 and 5. Also we can write so many multiples. Now between these two are, which are the common multiples? Common multiples, but that means 2 are 4 and 5, or we can say 4, 5 and another number, no problem. More than 2 numbers, then we can find common multiples. Now look dear students, here are the common multiples of 4 and 5 is 20, 40. If we go to the list on, then we will get, so we can write common multiples of 4 and 5 are 20, 40. Similarly, we will get 60, 80, like this one, unlimited. So these are the common multiples of 4 and 5. So we can say what is the common multiples. Now LCM. What is the meanings of LCM? The full form of LCM, least common multiples. This CM, this is common multiples, and L, this is indicate least, that means smallest number. Now dear student, look, they are the common multiples of 4 and 5. Now what will be the LCM of 4 and 5? The least, that means smallest common multiples. Look, 20, 40, 60, 80, they are the multiples. Now common multiples 20. So we can say LCM of 4 and 5 is 20. So LCM means least common multiples, that means the smallest common multiple. This will be our answer. So we can say LCM of 4 and 5 is 20. So at first they are the multiples separately, then we have to write the common multiples, then we have to search the smallest common multiple, that means least common multiple. This is called in shortly LCM, and this is our 20. So now we will be able to solve LCM. Now dear students, we will go to the factors. And dear students, LCM is 20. This is our broadly method. And another method, you will be able to solve the LCM. This is our prime number method. Clear? You know, suppose 4 and 5, what will be their LCM? Now 4 and 5 by prime number method, this is called Euclid process. At great mathematician Euclid. Now we can say this is Euclid process. Now we have to take prime number. Now what is the prime number? We will discuss. Prime number. What is prime number? A number is called prime number if it has only two factors. Now what is factors? We will discuss. Two factors, one and itself. Then we call this is prime number. Okay dear student. So this Euclid process also we can find the LCM. We will discuss, no problem. At serially we will discuss. So now we discuss this theorem. Now factors. Dear student, what is factors? Suppose, what is the factors of 8? What is the factors of 8? It will be so many answers, so we can write what are the factors. Now what will be the answer? 1, 2, 4, 8. 1, 2, 4, 8. They are the factors of 8. Why they are the factors of 8? Because by using this number, we will be able to divide 8. We will be able to divide 8 without remainder. When a number can divide any number without remainder, then this number we can say the factors of that number. So here 1 is the factors of 8, 2 is the factors of 8, 4 is the factors of 8, and also 8 is the factors of 8. Look, 1 and itself, 1 and this is itself. The given number, 1 and itself, they always will be included within the factors. Clear? So what is the factors? Factors is a number that can divide the number, given number, without any remainder. So this is our factors. 5 is not the factor of 8. Why? Because if we divide 8 by 5, then remainder will be 3. But the definition of factors, when no remainder, that means remainder is 0, then we will be able to say this is the factors. Now common factors. Suppose dear students, now we can write, look, suppose 8 and another one 12. Suppose this two one. The factors of 8, 1, 2, 4 and 8. And 12, their factors 1, 2, 3, 4, 6 and 12. So they are the separately factors of 8 and 12. Clear dear students? Now we will go to the common factors. Now what is the common factors of 12? Common factors of 8 and 12 are which one dear students? 1, 2, 4, this one. So these three 1, 2, 4, they are the common factors of 8 and 12. So we will be able to how to find the common factors. Now GCF. GCF, the full form of GCF, greatest common factors. Now common factors, they are the common factors. Now if we say what is the GCF of 8 and 12? Now dear students, GCF of 8 and 12 is, now our definition said that greatest common factors. Now 1, 2, 4, they are the common factors of 8 and 12. Now which one is the greatest among these three? We can say 4. So our answer is 4. So 4 is the greatest common factors. Clear? So this is our answer. So 4 is our answer for 8 and 12. This is the GCF of 8 and 12. Greatest common factor. So now we can see what is the GCF. Now dear students, prime number. Already we know prime number, a number which can divide only 1 and itself. This is our prime number. So what is the prime number? Prime number is a number which can divide, which one is divisible by only 1 and itself. That means 1 and itself. So by using 1 and itself, we will be able to divide without remainder. So we can say 1 and itself, these two on, they are the factors of prime number. Factors of prime number. Dear students, so we can say how many factors of prime numbers? 2, only 2. We can say only 2 factors. So this is your another important short question. How many factors have any prime number? So any prime number, there are 2 factors, 1 and itself. Now suppose 2 is a prime number, 3 prime number, 5 prime number, 7 prime number, 11 prime number, 13, like this one. Why they are the prime number? Because every number they has only 2 factors. Now this one, factors 1 and 2, this 1 and 3, this 1 and 5, this number 1 and 7, 1 and 11, and then 1 and 13. Now look, 1 is this one, and 2, 3, 5, 7, 11, 13. That means itself, this number, given number. So when the factors only 2, 1 and itself, then we will be able to say they are the prime numbers. Now dear students, if question said that why 1 is not a prime number, suppose in your short question this is said that why 1 is not a prime number. So what will be the answer? We can say why 1 is not a prime number. Why? Now what will be our answer? We will write 1 is not a prime number because it has only 1 factor. This is the main reason. The number 1, it has only 1 factor, and which one? This itself, 1. The factors of 1 is 1 itself. But we know every prime number contains 2 factors. But 1 has only 1 factor, so we can say 1 is not a prime number. Very simple. Suppose why 12? Why 12 is not a prime number? We know. So we can write 12 is not a prime number because it has. What will be the answer, dear students? Try to think. What will be the answer? Because it has 12. It has, look, it has more than 2 factors. Very simple. This is not necessary to show it who are the factors of 12. Not necessary. We can write 12 is not a prime number because it has more than 2 factors. When exactly 2 factors, then we can say this is the prime number less 1 factor, so this is not a prime number. And 12 and another number, they have more than 2 factors, so we can say they are not prime number. Now dear students, prime factors. The prime number is called the prime factors. Look, suppose 12. What is the factors? 1, 2, 3, 4, 6 and 12. They are the factors of 12. Now look, 2 and 3. This 2 on, they are the prime numbers. So we can say 2 and 3, they are the prime factors. If question said that write the factors of 12, write, dear students, look, write the factors of 12. Now you have to write 1, 2, 3, 4, 6 and 12. If question said that write the prime factors of 12, write the prime factors of 12, then you have to write only 2 and 3. Because here 2 and 3 only prime factors, and there everyone they are factors, but 2 and 3 they are only prime factor because they are prime number and also factors, so we can say they are prime factors. Now dear students, prime factorizations. Suppose our 12, suppose 12, look, this is 2 is a prime number and this is the smallest prime number. Now if we divide, this is 6, again if we divide by 2 it will be 3. Now we can write 12 equal 2 into 2 into 3. Look, 2 into 2 and into 3. Then we can write 12 equal as like 2 into 2 into 3. Look, 2 prime number, this 2 also prime number, this 3 also prime number, and they are using by multiplication sign. This is the product, and if we find the product it will be 12. So for 12 we can write 2 into 2 into 3. This process, this system, this is called prime factorization. That means if by using the prime number, if we express any number as a product, as a using by multiplication sign, then this is called prime factorization. And they are each factor, they are prime factors. Now dear students, sometimes your question said that in your short question or creative question, express 16 as a prime number, express 16 as a product of prime number, or question said that express 16 as a prime factorization. Now what will be your answer? 16. Now look, 2, this is 8, again 2 divide, this is 4, again 2, this is 2. So 2 is a prime number, not necessary. Now we can write 16 equal 2 into 2 into 2 into 2. So this is our process. So we can say 16 equal this one. This is the system of prime factorization or product of prime number. Okay dear students. Now dear students, we will discuss our all topics. Now dear students, we will discuss LCM and GCF also. Now how can we solve LCM by using Euclid process? Suppose 6, 8, 10. What is their LCM? Now by using Euclid, at first you have to take prime number. Remember, you have to take prime number and smallest prime number, and you have to take this number such that there are 3 numbers. Among 3, at least 2 numbers they will be divisible. Suppose 2, 3, 4, 5. All numbers are divisible. At least 2 enough. Now 3, 4, 5. No number. So we can say LCM of this one, which will be 2, 3, 4, 5. Now if we multiply, 4, 5 is 20, 20 3 is 60, and 120. So dear students, what will be our answer? 120. This is our LCM of 6, 8 and 10. So 120. This is the process of Euclid process, having very smallest, having very smart process. And by using Euclid process also we will be able to find the HCF. Now what is the HCF? For HCF you have to take the number which will be divisible, which can divide every number. LCM at least 2, but for HCF all numbers. Suppose 2. Now 3, 4, 5. So this 2, this is our GCF. Clear dear students? Now you will be able to solve. Now your homework, exercise 5, 1 and 2. Exercise 5, 1 and 2, all. This is your homework. I hope you will be able to solve it. Next class again we will discuss chapter 5. Thank you dear students. No more today.